Okay, hello everybody. We're going to look at section 5.2, right triangle trigonometry. 5.2, right triangle trigonometry. Involves 6 trigonometric functions that we will examine in this section and beyond. And these 6 trigonometric functions are functions of angles, and we call them sine function, and we show it as sine of some angle theta. This is my y value. Y is equal to f of x sine of theta. Y is equal to cosine of theta. Y is equal to tangent of theta, and y is equal to cotangent of theta. So we can write these names of these functions as sine function, cosine function. Notice the prefix co there, the co in front of sine, and tangent, and then we have a co in front of it, cotangent. And I will mention that these co's are referred to co-functions. Okay, these are co-functions of each other. These two are co-functions of each other. These two are co-functions of each other. And we have 2 more. Y is equal to secant of theta, and y is equal to cosecant of theta, or we can write it as co-sec of theta, and this is called secant, and this function is called cosecant function. Okay, and these 2 are co-functions of each other. We will define these on a right triangle, what these functions represent. These functions represent some ratios, okay? And what are those ratios? If this side, the length of this side is A, and the length of this side is B, and the length of this side is C, let's label them this way. And then let's say this angle is theta. Given these sides and letters, we can find and we can define these 6 trigonometric functions. Okay, sine is defined. Okay, sine is defined as sine of theta is defined as the opposite side, the length of the opposite side divided by the length of the hypotenuse. Opposite side to the angle. Okay, the opposite to the angle. If the angle is on the other side, let's say here, then the opposite would be B. Okay, in this case, the opposite is A. So we say opposite is A, and then hypotenuse is always this biggest side of a right triangle, and that is C. A divided by C is the ratio sine of theta. So this is very important. These are functions, and all of them take angles as their independent variables. Okay, these are some angle, and this is some ratio. What type of ratio? In this case, sine. These sines are cosine, tangent, all of these are ratios. The entire functions are ratios, and then inside we have angles. Sine, what kind of ratio? It's opposite divided by hypotenuse. Cosine, what kind of ratio? We will define that as adjacent divided by the hypotenuse. So let me write these down again. We have a right triangle, and this side is called, let's say, A, this side is B, and this side is C. Then I have sine of theta is A over C, which is opposite divided by hypotenuse. Okay. And cosine of theta is adjacent, B adjacent, which is labeled as B, adjacent to the angle here, divided by hypotenuse, which is c. And tangent theta is defined as opposite divided by adjacent, which is a divided by b, that is opposite divided by adjacent. Okay. What are the other three functions? How are they defined? They're actually related to these first three, because I will mention that once I define these, I'll mention that these 6 trigonometric functions are closely related to each other. Sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocal. Reciprocal means 1 over each other. You just flip the fraction. Okay, let's demonstrate what I mean here. Cotangent theta is defined as b divided by a, which is adjacent divided by opposite. Okay, adjacent divided by opposite. B divided by b divided by a is called cotangent ratio, cotangent of that angle. And secant of theta is c divided by b, which is hypotenuse divided by adjacent side, the length of the adjacent side. And cosecant theta is defined as hypotenuse c divided by opposite side. In this case, opposite is a. Okay. Now, let's take a look and notice that, let me take a different color pen here. Notice that these are related, tangent and cotangent. What do you notice here? A divided by b, b divided by a. Tangent and cotangent, we flip the fraction, we take the reciprocal. Cosine and secant, what do you notice between b over c and c over b? B over c, flip it, c becomes c over b. Okay, cosine and secant. You can remember this way. You can remember the order I put these in: sine, cosine, tangent, cotangent, secant, cosine. The co-functions are easier to remember, the original and then co-version of it, the co-function version of it, tangent and then the co-function of it, cotangent, secant. And also you can remember this way: this is C and this is S, the other way around, C versus S. Not C, C, but C and S and C. Here again, S and C. Sine, A over C. Cosecant is C over A. So to find cosecant, you just flip the sine ratio, A over C, or opposite over hypotenuse becomes opposite over hypotenuse, becomes hypotenuse over opposite. And again, cosine and secant, adjacent over hypotenuse turns into hypotenuse over adjacent, flip the ratio, and then you get secant from a cosine. And tangent, cotangent, you flip this, A over B becomes B over A. Opposite over adjacent becomes adjacent over opposite. Okay. This picture this visual represents reciprocal identities, which means sine and cosecant are reciprocals of each other. How do we write that? We write it this way: sine of theta is equal to 1 divided by cosecant theta, or cosecant theta is equal to 1 divided by sine theta. Okay, and this is true. And cosine theta is 1 divided by secant theta, or secant theta is equal to 1 divided by cosine theta. They're reciprocals of each other. And tangent theta is 1 divided by cotangent theta, or likewise, cotangent theta is equal to 1 divided by tangent theta. Okay. This leads us to interesting identities. For example, sine. Actually, it's not. Maybe it's not very interesting, but the sine times cosecant will be 1. Cosine times secant will be 1, and tangent times cotangent will be 1, because these are reciprocals of each other. When you multiply these, you will get 1. Multiply these two, you get 1. Multiply these two, you get 1. For example, 1 half, 1 divided by 2 versus 2 divided by 1. Flip it. And half times 2 is 1. If this was 1 divided by 3, this will be 3 divided by 1. 1/3 times 3 over 1 is 1. And if this was 2, this was half. 2 times 1/2 is 1 again. So we can represent those this way. Sine of theta times cosecant theta is equal to 1 because we could write this as sine of theta times cosecant could be written as 1 over sine theta. I already wrote that earlier. And then sines cancel each other. This is sine over 1, so sines cancel, you get 1. And this is true for cosine of theta times secant theta is 1, and tangent theta times cotangent theta is also 1. These are some identities we call reciprocal identities. Okay? And one last comment on identities. Because tangent theta is defined as, in a given right triangle, as ABC here, theta, because tangent is defined as opposite divided by adjacent, opposite divided by adjacent, we could represent this as tangent theta is opposite divided by hypotenuse and adjacent divided by hypotenuse. What I did here is I didn't change the fraction, which means I divided the top numerator by the hypotenuse, but I cannot do that just one side. If I do it both sides, top and bottom, or numerator and denominator, both at the same time, then I'm not changing the fraction, which is allowed. I can do that. I'm allowed to do that. So I divided the opposite by hypotenuse, but then in the denominator, I divided adjacent by hypotenuse, the same hypotenuse as well, because if you think about it, these hypotenuses will cancel, and then you will end up with the same original ratio, opposite over adjacent. So this is fine. I can do this. But the reason I did this is because opposite divided by hypotenuse, if you remember, opposite divided by hypotenuse is sine, and adjacent divided by hypotenuse is cosine. So I can write this is sine of theta divided by cosine of theta. So sine divided by cosine is actually tangent. So tangent is equal to an adjacent over hypotenuse turned into cosine. All right, so tangent is sine divided by tangent theta is equal to sine theta divided by cosine theta. This is always true. And cotangent theta is, flip this, right? This is reciprocal. Tangent and cotangent are reciprocals of each other. Remember this. The middle two here, tangent, cotangent, these are reciprocals of each other, reciprocals of each other. By reciprocal, I mean 1 over, flip it. A over B becomes B over A. So tangent and cotangent, I can flip them, and cosine over sine. Okay, cosine over sine theta. All right, and these are the final identities, reciprocal identities we can write. Now, let's do some examples with these facts, using these facts, okay? For example, if I have example 1, if I have a right triangle given to me as 7 here on the opposite side and 17 on this side, okay? And then I want to find exact values for the 6 trigonometric functions of the angle theta given in this right triangle. Okay, find the exact. I highlight this word exact because if I have square roots, any type of irrational number, I can use my calculator, but my calculator will give me approximate values, approximated to some decimal points. But I don't want that. I want exact values, which means keep the radicals, roots, and then simplify as much as you can. And then if the radicals are in the denominator, you rationalize it by multiplying the numerator and denominator, top and bottom, by that root. Find the exact values of the 6 trigonometric function values of theta. Okay, I know the opposite side is 7, or to theta, opposite to theta. And adjacent side, adjacent to theta, is 17. I don't know hypotenuse yet. But we can find the hypotenuse if we know two sides of a right triangle. We can find the other side of the right triangle using what we call Pythagorean theorem, which you heard many times. Pythagorean theorem says 7, 17, and let's say c. 7 square, a square plus b square, is equal to c square. Okay. 7 square is 49, and 17 square, I can multiply 17 by 17. 17 times 17, 49, 119, and then 17, 289. 289. Okay, that's 17 square. And I can add these two, 289 plus 49, 8, and 3, and this gives me 3. 338, that's correct, 338 is equal to c square, and c is root 338. Okay. When you break this into its factors, okay, 169 times 2. What is 169 times 2? That's 338. Okay. So to factor these numbers, to simplify, my point is this is correct answer, 338. But as I said before, we want to simplify these roots as much as we can. To simplify, start dividing by 3, and then if you can't, if it's an odd number, then go to 3. If it doesn't divide, go to 5. So try these numbers, 3, 2, 3, 5, 7, in this order. And we call these prime factorization. Try these primes. 2 is dividing 338, and then 338 divided by 2 is 169, okay? Because 160 times 160 is 320, plus 18 is 338. That's correct. And then 169 can come outside as 13. So this is 13 root 2, okay? 13 root 2 is a better representation of the hypotenuse, okay? 13 root 2. Once I know these three sides, opposite, adjacent, and hypotenuse, then I can construct all my ratios. Opposite divided by hypotenuse sine, adjacent divided by opposite cosine, opposite over adjacent is my tangent, and then the rest, the other three, we just flip them. Okay, so we have sine of theta. Let me redraw it here. 7, 17, 13 root 2. Theta is here. Theta could be somewhere else, so be careful. The opposite to theta is 7. Opposite to theta is 7, and 13 root 2. Get 7 divided by hypotenuse. Opposite divided by hypotenuse is my sine function. One last point. This is not done because I have a radical in the denominator. If we have a radical in the denominator, only denominator, not numerator, only the denominator, we rationalize it, which means we multiply this. This is correct answer, but it is not the final answer, because final answer we want to rationalize these fractions. So multiply both top and bottom by the root term, root 2 divided by root 2. 7 times root 2 is 7 root 2. And 13 stays. 13 times 1 is 13. And then root 2 times root 2, like think of as if there's a 1 in front of root 3. The numbers are multiplied together and roots are multiplied together. 13 times 1 is 13. Root 2 times root 2 that is root 2 square, and this square term and root term cancels each other, and then you end up with 2. Okay, so that's times 2, and that is 7 root 2 divided by 26. Okay, 13 times 2 is 26. 7 root 2, 26 is the correct answer for sine of theta. Okay, rationalized version, simplified version, 7 and 26 cannot cancel further, and that's correct. Okay, cosine of theta is adjacent side, the length of adjacent over the length of hypotenuse, which is 17 divided by 13 root 2. And then again, we rewrite this and multiply top and bottom by root 2. So we get 17 root 2 divided by 26. Root 2 times root 2 is 2. 13 times 2 is 26. Okay? And this is the correct answer for cosine of theta. Finally, tangent theta. I will go ahead for the other three after tangent. I will go ahead and reciprocate these, just flip these, and then I'll be done. Instead of constructing the ratios, hypotenuse divided by adjacent. I could do all those as well, but this will be quicker. Once I find the first three, I can find the reciprocal, just flip them and find the remaining three. Opposite side divided by adjacent side, that is 7 divided by 17. That's final because there's no roots. These are numbers and they cannot cancel each other. There's no common factors. So 7 opposite divided by adjacent, which is 17, and I'm done. Okay, this is the fun part. Cotangent is, instead of writing adjacent over opposite, which is 17 divided by 7, that's true. I'll just go ahead and flip this. 17 divided by 7. That's correct answer for cotangent. Okay. What is secant theta? Secant theta is 1 divided by cosine, which means flip the cosine function. Take this here, root 3, 13 root 2 over 17. And then cosecant theta is, remember these reciprocal identities here. Secant is 1 over cosine. C and S are different. You see C, S versus C. And then cosecant is 1 over sine. Okay, cosecant is 1 over sine. You flip the sine function, ratio of the sine. Sine ratio. Cosecant will be 13 root 2 divided by 7. 13 root 2 divided by 7. And I'm done with 1, 2, 3, 4, 5, and 6 trigonometric ratios or trigonometric function values for this angle theta. Okay, so this is angle and this is ratio. Independent variable x, dependent variable y. Y's are ratios here, and then x's are angles inside the function, just like log of x, log of theta, secant of x or secant of theta, and these are all functions. Okay. What if I did not want to use these reciprocal identities? I can still find my cotangent, secant, and cosecant using their definitions. If you redraw the right triangle, 7, 17, 13 root 2, theta. Cotangent of theta, don't forget the theta because these are functions, okay? The cotangent of an angle is equal to some ratio, and that is adjacent divided by opposite. And that is adjacent to the angle, and opposite is opposite to the angle. 17 divided by 7. That's what I found earlier anyways. Same. Secant theta is the ratio hypotenuse divided by adjacent side. That is 13 root 2 divided by 17. 13 root 2 divided by 17. And cosecant theta is hypotenuse defined as hypotenuse. This is hypotenuse. Hypotenuse is always the biggest side. This C. 13 root 2 divided by 7. 13 root 2, or opposite. 13 root 2 divided by 7, which is the opposite side. Okay. If you compare these, they're the same. If you look at these, cotangent was, let me see. Okay, cotangent was 17 over 7, 17 over 7. Secant was 13 root 2 over 17, yes. Cosecant was 13 root 2 over 7, yes. I found the same, both using the definition of these ratios, and also by using the reciprocal identities. Okay. Let's do another example. And these examples can be found in my MATLAB exercises. I'm solving very similar ones, so you can practice further with my MATLAB. On my MATLAB. Exercise 2. Let's say we want to find, same question, the 6 exact values of the 6 trigonometric function values of this angle theta, given the two sides as 3 and 4. Okay. The hypotenuse is unknown, so I can do 3 square plus 4 square is equal to c squared, the hypotenuse squared. That is 9 plus 16 using Pythagorean theorem. Okay. Pythagorean theorem. Okay, Pythagorean theorem tells us c squared is equal to 25. Therefore, c is 5. Okay, so this is 5. Okay, now this is important. As I mentioned, the opposite is opposite to the given angle, the angle that is in consideration. We want to find sine of theta, cosine of theta, tangent of theta. Okay, this theta is here. Opposite to the theta is 3. So this is the opposite side. And then adjacent to the theta is this side, 4. Sine, okay, let's finish these. Sine is opposite divided by hypotenuse, opposite 3 divided by hypotenuse 5. Cosine, adjacent divided by hypotenuse 4 divided by 5. Tangent, opposite divided by adjacent 3 divided by 4. Okay. Once you write these, the rest 3, the remaining 3 are simple, because cosecant is, flip this, 4 divided by 3. Flip the tangent. For secant, you flip the cosine. So secant theta is 5 divided by 4, or hypotenuse divided by adjacent. Cosecant theta, flip the sine, which is 5 divided by 3. Okay. And those are the 6 trigonometric function values. That was an easier one because we didn't have any roots or radicals to rationalize, or fractions to rationalize. Okay. What if, example 3, what if I had an example where cosine is given, cosine of theta is given like this, and use a definition, I want to use definition or identities to find the exact value of the remaining trigonometric function values of angle theta. Given that angle theta is acute, theta is as an acute angle. Acute angle means less than 90 degrees. Okay, less than 90 degrees meaning we treat this, in next section we will see that angles could be above 90. If they're above 90, we don't have a right triangle anymore, so we use reference angles, reference triangles, and other definitions, other concepts to find the 6 trigonometric functions of any angle, section 5.3, next section. But for now, acute angle means less than 90, which means you have a right triangle, and go ahead and construct the adjacent as adjacent as 1, and then hypotenuse as 8, okay? Hypotenuse is 8. Adjacent is 1, and hypotenuse is 8. Adjacent divided by hypotenuse, because that's what cosine is. Given 1 over 8, you immediately should know that top is adjacent, bottom is hypotenuse. What is this side? Let's say opposite A. Letter A, let's represent this as the opposite side. How can I find this? Using Pythagorean theorem, this square plus this square is equal to this square. Okay, a square plus 1 square is 8 square. A square plus 1 is 64. And a square is 63 because you subtracted 1 from both sides. And root, take the root of both sides. And a root and square cancel. A is equal to root 63. Okay. So now you write your all the three sides, the values of all the 3 sides, root 63 and 8. Okay. Once you know these 3 sides, you can find all 6 trigonometric function values because they are ratios. This divided by this divided by this divided by this for tangent, this divided by this for cotangent, this divided by this for secant, this side divided by this side for cosecant. Okay, so let's write these down. Sine of theta, root 63 divided by 8. Cosine of theta, 1 over 8. Well, that's already given. And tangent theta is root 63 divided by 1, which is root 63 itself. Root 63 divided by 1 is itself. No need for rationalizing here, because we don't have a situation, we don't have any fraction here where this is root 63 actually. This is root 63. Sorry for my typo there, writing there. So root 63 is in the numerator. It has to be in the denominator in order to rationalize it. We don't want the denominators to have roots. Numerators are okay, like this is okay, it's in the numerator, that's fine. No roots here, it's in the numerator again, on the top, that's fine. Okay. How are we going to find the other 3? 2 ways, again, either use reciprocal identities or use the definitions. So once again, I will write root 63 here, and 1 and 8 theta, and cotangent theta is adjacent divided by opposite, 1 divided by root 63. And secant theta is hypotenuse, 8 divided by adjacent, hypotenuse divided by adjacent, which is 8. Cosecant theta is hypotenuse divided by opposite, root 63. I didn't circle these yet because I need to rationalize them because there's a root in the denominator. Okay, radical in the denominator, so I rationalize this. How? Let me zoom out here, rewrite it. 1 divided by root 63 can be multiplied by root 63 divided by root 63, which is 1, so I'm not changing the fraction, I'm just writing in a different form, rationalized form. So root 1 times root 63 is root 63. Root 63 times root 63 is square root of 63, root 63. I mean, square of root 63. Square and root cancel, and that ends up with 63 only. And that is the correct answer for cotangent, 63 over root 63 over 63. Okay. And this is true for any number. If you have 1 divided by root some letter, let's say A, that is root A divided by A, always true. If you have 1 divided by any other letter, let's represent it like, let's say root 10, that is root 10 divided by 10. That's true for any number. Okay, these are just examples. Okay, back to cosecant. Cosecant is 8 divided by root 63. I multiply both top and bottom by root 63. And 8 root 63 divided by roots cancel. I end up with only the number inside, 63. And that is my correct answer for cosecant. Okay. This is our part 1 first video on this introductory chapter, right triangle trigonometry, and I will see you next time.